Chapter 2 Variables, the Holders of Information. In this chapter, you will learn about variables, which are used to hold data. Since we use computers primarily to manipulate data, we need to begin the study of programming with learning about variables. We will examine the different kinds of data and how variables are classified according to the data they hold. Once you understand variables, you can begin to learn about programming statements, which are the fundamental building blocks of programs. The first statement we will examine is the assignment statement, which allows you to store data into a variable. I will cover the topic of variables as necessary holders of data. You'll examine variables by their types, that is, what kind of data they are intended to hold. I'll define programming statements, the necessary building blocks of programs. Next, I'll cover how to introduce a variable into a program, variable declaration. Finally, the topic of loading variables with data will be covered, how the variable is assigned in its data. In this chapter, variables as holders of data. Types of variables: integer, real, character, and string. Variable declaration. Programming statements. Assignment by the programmer or by the user. A place to put data. One of the computer's most treasured assets is its capacity to store and manipulate information. Data, plural for datum, is another term for this information. Most programs that programmers write will need to put this data or information into some type of holder in order to manipulate it in some manner. We see the need to manipulate data everywhere in our society. Changes of address, phone number, new passwords for accounts, and editing manuscripts illustrate the need to manipulate information. Programs are constantly updated. A programmer might want to edit some information, change it, print it, or perhaps send the data over the internet through some file. Data has to be put somewhere, and programmers use holders for it. 3 examples of data are the number 365 to represent the days in the year, the number -20F to represent the Fahrenheit temperature in Alaska on a winter day, the name of a favorite actor, Tommy Lee Jones. These 3 pieces of data, 365, -20, and Tommy Lee Jones, are all pieces of information that a programmer would have to store in holders. When we use holders, we try to give them descriptive names so that readers of the programs can understand what we are trying to do in our program. Let's devise some appropriately named holders for our data. We could put the number 365 into a holder called days, the number -20F into a holder called temperature, and the name Tommy Lee Jones into a holder called actor. Now, instead of referring to 365, -20, or Tommy Lee Jones directly, we refer to the holders days, temperature, or actor, which a programmer uses to manipulate data that often changes or varies over time. Suppose you want to change 365 to 366 because you are dealing with a leap year. A programmer would manipulate the holder days rather than the number directly. Should you want to change the name of your favorite actor to Will Smith, you need to put the new name inside the holder actor. Likewise, to reflect temperature changes in Alaska, we use the holder temperature to alter the degrees. One can never be certain whether data in a program will change right away or later on. You also don't know how often a piece of data will change during the running of a program. Having a holder that contains data facilitates managing that data. Here are some examples. A programmer would write instructions to do the following. 1. Increase the number in days by 1. 2. Get another name of an actor and put that name into the holder actor. 3. Change the value in the temperature holder to the current reading. These examples illustrate the need for a programmer to manipulate the variables through the values through their holders, since the instructions can be written for the holders rather than the numbers themselves. The programmer thus controls the data via the holder name. See Figure 2.1. Let's look at Figure 2.1 there. Figure 2.1. The programmer accesses data through the holder names used in his program. So programmer, days, 365, temperature to -20, and actor to Tommy Lee Jones. Back to the text. Now, to the real name of these holders, variables. Variables are holders of data, in particular, data we expect to change or vary over time. In computer languages, the word variable differs slightly from its meaning in algebra. Variable names are not simply the letters of the alphabet. They are like X and Y, which many of you might remember from your study of algebra. Variables can be any descriptive names that help us understand what the data means. That's why we used variables to name days, temperature, and actor to label or identify the raw data of 365, -20, and Tommy Lee Jones. Note: variables in algebra are letters of the alphabet, like X and Y, but in computer language they can also be any descriptive names like sum, answer, or first value. Tip: if you want to link two words together to make an interesting variable name, use the underscore character. For example, first underscore sum and my_last_answer. Examples using variables. This example shows why it is easier to write a program using a variable rather than a number/value directly. The temperature variable from the previous section could be used as a holder for a given daily temperature in Anchorage, Alaska, during the last week of February. As the temperature changes each day, a new value is put inside of the temperature holder or variable. Look at the graph there. Temperature, Sunday 15, Monday 18, Tuesday 6, Wednesday 21, Thursday 19, Friday -4, Saturday 2. One way to view what a variable might look like as its values are changing is to show the variable and its values as they are being replaced. Each new value replaces the previous one until the final value is left there, as least for now. Temperature 15, 18, 6, 21, 19, -4, 2. If a programmer wants to write a program to print the average daily temperature during the first 4 days of the week, he could devise 2 algorithms to do this, one using the variable temperature and one without that variable. Algorithms with temperature as variable, algorithms without variable. So let's look at algorithm with temperature as the variable. 1. Enter a value in temperature. 2. Print actual temperature for the second day. 3. Print actual temperature for the third day. 4. Print actual temperature for the fourth day. Algorithm without variable. Print 15, print 18, print 6, print 21. The algorithm without the variable is very inefficient, and it is dependent on exact values being known at all times. The algorithm using the variable temperature is not dependent on knowing what value is within temperature. It is enough to know that whatever the temperature is, it will be printed. Comparison of 2 variables. In another example, we will use 2 variables and continually compare one value against a second value in terms of whether a first value is less than, greater than, or equal to the second value. Think of a flight of stairs with one variable representing the number of steps you have climbed, and the other variable representing the top step. The first variable will be called count bottom feed steps, and the second variable will be called top step. See figure 2.2. Let's look at figure 2.2. Count steps is shown on the landing at the bottom of a flight of stairs, and top step is shown at the top of the steps. Continue on with the text. We will continually increase the value of count steps, and each time check its value against top steps value. If count steps is still less than top steps, it means we have not yet reached the top of the stairs, and so we should continue to increase count steps by 1. when count steps and top step are equal, we know that count steps and has reached the top of the flight of stairs, and the program should end. In this example, the number 10 is placed in the variable top step. The value 0 is placed into count steps, representing the fact that we are at the bottom of the flight of stairs. Look at the values of count steps at the beginning of the program. Count steps 0. This statement reports that count steps starts off as 0. 1. Count steps changes to 1. Now, count steps is compared with the top step in terms of being less than, greater than, or equal to top step. Count steps is less than top steps. Since count steps value is less than top steps value, the execution of the program continues. Count steps increases to 2. Count steps is less than top steps. This pattern continues. 3 count steps is less than 10 of top steps. 4 count steps is less than 10 of top steps. This pattern continues until we view the program near the end of execution. 9 count steps is less than 10 top steps. Until now, the variable count steps has been less than top step, or 10, but now, count steps 10 is equal to top steps 10. The last value for count steps is 10, and it is compared with the value in top step. Since count steps value is not less than top steps but equal to it, the program stops. This example illustrates the ability of the computer to alter one variable repeatedly. The decision to alter this variable depends on its value in comparison to another fixed value, top steps. As the program executes, the focus shifts back and forth between count steps and top step, with count steps steadily increasing as the program runs. In one programming statement, count steps is increased, and in the next statement it is compared to top step. The programmer uses this algorithm to do all the work. Here is an algorithm to count the number of steps and then ring a bell when you get to the top. 1. Set count steps to 0. 2. Set top steps to 10. 3. Increase count steps own value by 10. Number 3. Increase count steps own value by 1. 4. Check count steps value against top steps. 5. If count steps is less than top step, go back to step 3. Otherwise, go to step 6. 6. Ring a bell. On the CD, a program that increases count steps and compares it with top step is written in C++. Different types of variables. Now that we have both introduced and the term variables and looked at some examples involving them, it is important to classify variables according to their types. The type of a variable is the kind of holder is the kind of holder needed for the kind of data being stored inside the variable. In our previous examples, days and temperature were holders for the same kind of data, a number. The actor variable is a different type because it contains 3 words, Tommy Lee Jones. So what types of variables are there in most computer languages? The main division in data types is between numbers and letters. Data is then further subdivided into groups under those headings. See Figure 2.3. Figure 2.3. In the first diagram, the 4 main groups of data types are listed under their appropriate headings. Then another diagram gives the specific names of these 4 main groups. Data types, general subdivisions. Numbers branches to integers and non-integers. Letters branches to a single letter and several letters. Specific types, though. Numbers branches to integers and real doubles. Letters branches to a character and a string. The integer type. Back to the text. Integer type. Integers in computer languages are defined as numbers that have no fractional parts. Some examples of integers are as follows: -20, 42, 13, 1, 475, -234. The real type. Numbers that are not integers can be called real. In the computer language C++, real numbers are stored in a type called double, which refers to the fact that 2 bytes of memory are needed for its storage. 14.62, 58 1/3, -5.76, 0.213, 17.36. Each of the numbers in this list has a fractional or leftover part, so to speak. This puts them in our second category, the real type. The term real refers to all other numbers that are not integers. 14.62, 58 1/3, -5.76, 0.213, 17.36. The character type. Now consider the character type. The character type is a variable that will hold a letter of the alphabet, or a symbol found on your keyboard, like the pound sign, the star sign, the exclamation point, and so on. We use single quotes to set off characters to distinguish them from variables, which sometimes can be taken for characters. Compare the character A with the variable called A. Which symbol or letters are considered characters? There is a standard list of characters in the American Standard Code for Information Interchange, also known as the ASCII, pronounced ASCII chart. It includes the alphabet in both upper and lower case, as well as all the symbols on a keyboard. If you use any of these letters or symbols, you will need a character type variable to hold it. For a copy of the ASCII character chart, please see Appendix D. Examples of non-ASCII characters would be special letters from foreign languages, such as the C with a line beneath it, for example, or special mathematical symbols like pi. More examples: G, the percentage sign, the addition sign, and the little letter K. Tip: characters are generally displayed with single quotations to avoid confusion with variables that have the same name as a character. In the previous example, the letter G would be considered a variable named G, or it could be the letter G as a character. By putting single quotes around it, we emphasize that we are talking about the letter G, which is a character there. The string type. The string type is a variable holder that can only contain strings or groups of letters or symbols. The string type allows words to be stored by the computer. The ability of the user to enter a word is via the strings types. Let me read that sentence again. The ability of a user to enter a word is via the string type. Strings are used for a sequence of characters because the character type can only hold one character at a time. Later, we will see that there are other ways to handle a sequence of letters. Here are some examples. Washington, D.C. Hello, my name is Jack. And the colon sign, the and sign, star, percentage, and money sign. Think of a string as a string of beads in a necklace. Except here, we mean a string of characters strung together. See Figure 2.4. Figure 2.4. Each example is shown as a string of beads in a necklace to emphasize that each letter is separate but also connected to the next letter as far as the computer is concerned. Back to the text. Note: the word type in computer programming language refers to the kind of holder needed for data. Type example: integers 1, 2, -38, 327. Reals 3.82, -14.6, and 0.005. Characters: G, the percentage sign, the addition sign, and K. String: robot, stars and stripes, wow. Introducing a variable for the first time in a program. Now for an explanation of the most interesting and basic part of programming, the ability to store data or information in a variable. The initial step is writing a computer program. The initial step in writing computer program is to tell the computer how much memory to allocate or set aside for the variables used in the program. The computer must know whether the variable being used requires a lot of memory or space, for instance. Once the computer knows what type of variable is being used, all the rules that govern that particular type must be followed. These rules will be explored later as you learn more about the programming. In order to tell the computer what type of variable will be used and how much memory is required, we must declare a variable. Declaring a variable is the same as introducing the variable. It is the first time you tell the computer what the variable's it is the first time you tell the computer what the variable's part will be in the program. The relationship or type of a variable must be identified so the computer can respond appropriately. The different types of variables previously mentioned, integer, real, character, and string, all make different demands on the computer. For example, different types require more memory than others. A character requires less space for storage than a string. Likewise, an integer requires less memory than a real type on most computers. By stating the type of a variable used in the program, a programmer is instructing the computer to allocate a certain amount of memory for that variable. An analogy, telling the audience who is who. The analogy of a playbill is useful since we are likening the computer to an audience. An audience wants to know who is playing what part, as well as the kinds of roles in the place. The computer is the same way. It needs to know what part each variable is playing so it can respond accordingly. Variables have different memory requirements for storage, and the manner in which they are stored depends on their types. A computer has to know this before the variable appears later in the program. Think of the play Hamlet by William Shakespeare. When you open the playbill to the first page, the list of characters and their parts in relation to the whole are listed. See Figure 2.5. Take a look at Figure 2.5. This shows the entire cast of Hamlet. Cast of Hamlet. Claudius, the new king of Denmark. Hamlet, son to the late and nephew to the present king. Fortinbras, Prince of Norway. Polonius, a lord and high officer, probably Lord Chamberlain. Laertes, his son. Horatio, the friend of Hamlet. Voltimand, Cornelius, Rosencrantz, Guildenstern, Ostrich are courtiers. Marcellus, a Danish officer. Francisco, Bernardo, soldiers on sentry duty. Reynaldo, servant to Polonius, a Norwegian captain. Players on tour. Two clowns, grave diggers. English ambassador, a priest, a gentleman, soldiers, sailor, messenger, and various attendants. Gertrude, Queen of Denmark and mother of Hamlet. Ophelia, daughter of Polonius, and ghost of Hamlet's father. Continuing on with the text. Hamlet is a prince, while Rosencrantz and Guildenstern are courtiers. Lesser known Francisco is a soldier. Gertrude is a queen, and Hamlet's father is a ghost. A playbill lets the audience know who's involved in the play and what part each character plays by the description of the character. From reading the cast of Hamlet, we know that Gertrude is a member of royalty, while Rosencrantz and Guildenstern are not. Imagine a playbill with the following heading: My First Computer Programmer, starring the integer, my first sum, the integer, my last sum, the real answer, the character, middle initial, the string, last name. The type of each variable is written on the left, while the name of the variable is written on the right. This playbill is useful because we can find out that there are two integers in this program, one called my first sum and another called my last sum. There is one real called answer, a character called middle initial, and a string called last name. Each of these players has a proper name, a name that the audience would recognize. My first sum, my last sum, answer, middle initial, and last name are the names of the players in this program. They take part in the program and appear at different points in the program in order to perform different tasks. The fact that one of the variables is an integer, while the other is a real, is comparable to saying that one of the characters in Hamlet is a queen, while the other character is a maid. This play, My First Computer Program, also has two integers in it, my first sum and my last sum. These names are useful since they allow you to distinguish one integer from another. Most programs have several variables, and often a few from each type category. Using the proper name to refer to the variables is a way of distinguishing among variables of the same type. This proper name is called the identifier of the variable to distinguish it from its type. Look at the following chart that mixes some of the types from both the program and the play. Each character in the play has a type, just as each variable does. Is the character in the play a friend of Hamlet's, a relative, a member of the ruling class? Is the variable an integer, a character, a string, or real? Characters in play, variables in program. King, Claudius, integer, my first sum. Queen, Gertrude, integer, my last sum. Courtier, Rosencrantz, real, answer. Type, identifier. Queen, Gertrude. Prince, Hamlet. King, Claudius. Integer, my first sum. Integer, my last sum. Courtier, Rosencrantz. Courtier, Guildenstern. Real, answer. All programs require that a variable be declared, that is, their type and name are stated before they are used in the program to do something really useful. Imagine what would happen if you were watching a play, and that an unidentified character appeared in scene 3, for example, and spoke with other characters before leaving the stage. Your first instinct would be to check the playbill and make sure you had not overlooked this character. However, what would you think if the character wasn't listed there? You would have to spend the rest of the play trying to figure out what connection that character had to the other characters in the play and the play as a whole. The computer is the same way. It cannot encounter a variable halfway through a program unless it had been declared prior to use. This is one of the most important concepts that must be understood. It's not that all languages require that all variables be listed at the top of a program, though many do, but they must at least be declared prior to being used in the program. Note: names for variables, as essential as the names of characters in a play, should be descriptive to enable any reader to follow what the variable will be used for in the program, e.g., checksum, last name, initial balance, etc. Caution: don't underestimate the importance of declaring a variable, because the computer must know how much memory to set aside for it. This must be done before the variable is used in the program. A word about statements. Computer languages, like spoken languages, have certain grammar that must be followed. The first point about writing in a programming language, is to write in sentences or statements. Computer statements are the building blocks of programs, just as sentences are the building blocks of paragraphs and essays. A program is comprised of statements. There are different kinds of programming statements: loop statements, if-then statements, assignment statements, and print statements, just to name a few. A statement in a computer language has rigorous grammar. As you learn each of these statements, you will take a moment to learn the grammar, often called syntax, of each statement type. This will save you a lot of time when you start to run programs. There is little or no room for variation, because the reader of your programs is a machine which will not understand what you mean to say if you do not expressly say it according to the grammar it understands. Termination of statements. The first point about programming is to understand how your computer language ends its statements. Do the statements end in a period or a semicolon? Most languages use the semicolon to indicate the end of a statement. Let's look at these statements from various languages. It is not important that you understand the statements, only that you recognize that each one ends in a semicolon. Example 1. C is equal to 14. Example 2. Answer is equal to 58. Example 3. While x is less than 14, C out, hello, N. In each of these examples, the semicolon is the last mark of punctuating after the group of words and symbols in the statements. In example 3, we have a statement that wraps to the next line, indicating that programming statements do not need to fit entirely on one line. Note: programming statements terminate with some sort of punctuation. Usually it is the semicolon. Must statements fit in one line? A programming statement need not fit on one line. Sometimes one statement, because of its complexity, will last several lines, and the semicolon will appear finally to indicate that the statement is complete. Another point about programming statements is that programmers like to indent. Indentation makes the programs easier to read and understand. In example 3, the line while x is less than 14, C out, hello, could have fit on one line, but writing it on 2 lines makes it easier to understand, as you will see later after studying this kind of statement. Note: a programming statement is not defined by its length. It may be longer than one line, or it may wrap up to the next line. Lines that wrap to the next line are easier to read and understand. Putting a value into a variable. Once variables have been declared, you are now ready to put a value into the variable. This is called assigning that variable. By assigning the variable, you are giving it a value for later use. If we try to print the contents of a variable on the screen, and that variable is unassigned or empty, then we have a problem. Caution: sometimes programmers forget to assign a variable, and then later try to use a variable's value, which produces erroneous and unpredictable results. Remember to assign the variable before using it. There are different ways of assigning a variable, depending on who does the assigning of values. So now I will formally introduce 2 important people in programming: the programmer and the user. The programmer. The programmer is the person who writes the program. Whether a programmer puts values into variables, he is the only person controlling what data is assigned to those variables. The programmer might use his own data to load the variables, or he might use an external source for that data, such as a file name. But the bottom line still holds: he is responsible for acquiring the data and assigning it to the variables. The user. The user is the person who interacts with the program. He will use the program much like the person who purchased an application, like Microsoft Word, at the store and uses it after installation on the computer. The user runs the program and responds to what the program asks. If the programmer has written statements to cause the program to pause and wait for a response from the user, then the user will be the one to assign variables. The user is prompted or asked by the programmer with some message that appears on the screen. See Figure 2.6. Figure 2.6. A message followed by a blinking cursor appears on the screen. Whatever the user types in response will go into the variable associated with this prompting statement. The prompting statement is, please type a number. Going on. How the programmer assigns variables. In an assignment statement, a programmer writes a variable followed by some symbol to denote that a value is being assigned, sent into a variable. To the right of the symbol is the value itself, or another variable. The syntax is as follows. Variable, left-hand side, assignment symbol is the equal sign, and the values are the right-hand side. Look at each of the following assignment statements written in their respective languages. Variable A is assigned to the colon equal sign, value is 35, language is Pascal. Variable A is assigned just equal sign, value 35 is C++ or Java. Variable is let A is assigned the equal sign, the value is 35, language is BASIC. Everything on the left-hand side is the variable A, while everything on the right-hand side is the value 35. The value 35 is being placed into the variable called A. The emphasis in assignment is that some value from the right-hand side is being shifted into the left-hand side of the assignment symbol. In the examples that follow, different values are assigned to different types of variables. Another important rule about assignment is that you must be careful about what values you put into which types of variables. In general, you must put a value into a variable of the same type. Integers go into integer type variables, reals go into real type variables, and so on. Here are some examples. Integers are being assigned to integer variables, such as answer 26, answer equals -14, sum is equal to 27. Characters are being assigned to character variables. First initial is equal to M, last initial is equal to W. Strings are being assigned to string variables. Name is equal to Janet, cousin is equal to Mike. And reals are being assigned to real variables. Balance is equal to 1,234.56. Amount is equal to 78.00. The one exception is that integers can fit into real types because integers are easily converted to real numbers, and the memory required for storing a real is generally larger than that required for storing an integer. Before the assignment statement is executed, a variable is empty and has no contents. Once the assignment statement is executed, the value is put into the variable. See Figure 2.7. Figure 2.7. Each variable is shown initially empty or unassigned, then is shown with its value inside it. Answer: -14. Sum: 27. First initial: M. Last initial: W. Name: Janet. Friend: Mike. Balance: 1234.56. Amount: 78.00. Assigning one variable to another variable. It is also possible to assign to a variable the contents of another variable. Let's say that you want an extra copy of a value that already exists in a variable called first val. All you have to do is declare another variable called copy val and assign to copy val first val's value. The syntax is as follows: variable left-hand side, assignment symbol equal sign, and the variable right-hand side. The variable on the right-hand side of the assignment symbol will have the value inside it copied into the variable on the left-hand side of the assignment symbol. If the variable is not empty, whatever is in it will be replaced with the new value. This is called assignment, assigning one variable to another. See Figure 2.8. Figure 2.8. Variables first val and copy val are shown with their respective values. Then the assignment statement is executed. Now the variables are shown again, this time copy val's value, -14, and changed to show the same value that is in first val to 27. Copy val, -14, first val, 27. Copy val is equal to first val, copy val is equal to 27, and first val is equal to 27. Back to the text. In another example, a variable is empty before being assigned to the contents of a second variable. See Figure 2.9. Let's look at Figure 2.9. Figure 2.9. The variable first initially empty is assigned the contents of the variable last. Then first is shown as an empty variable and last with its value 28. Then the assignment statement is executed, after which first has the same value as last. First, last. First, last is 28. First and last are both 28. Back to the text. Caution. The left-hand side must always be a variable, while the right-hand side can either be a value or another variable. When one variable is assigned to another, the right-hand variable does not change, only the contents of the left-hand variable. How the user assigns variables. It is important to let the user think of values for variables. The programmer should not be the only one thinking of values that will be assigned to variables. Think of the word input in English. Sometimes a friend will ask you, "What is your input?" She is really asking, What do you think about something when we look for the user's input? We are interested in what the user wants for values. There are 2 steps involved in understanding how you can get a response from the user stored into a variable. The first step is understanding how programming languages use the keyboard as a source of input. Input streams. Programming languages use an input stream as a source of values. Think of a stream in a computer language in the same way as you would a stream or a rivulet, a small river. Streams flow into larger bodies of water. In programming languages, an input stream is like a small channel that feeds from the keyboard. Anything that is typed at the keyboard will be sent to this stream. It is also visible on the screen. The stream is then a source of values, data, for the variables that will be assigned. See Figure 2.10. Take a look at Figure 2.10. Figure 2.10, a drawing that shows connections among the Figure 2.10. A drawing shows the connections among the user, the keyboard, the screen, the input stream, and 3 variables being assigned. The user is a woman, there's the keyboard, the screen, 28, 14, 36. The input stream is 28, 14, 36. Is assigned to A, B, C, where A is 28, B is 14, C is 36. Back to the text. Variables are assigned their values from this stream. Programming languages will differ in the way that they are handled. Programming languages will differ in the way that they handle the stream. One thing is common, however. Every programming language uses some word to indicate that an input stream is the source of values for variables that will be assigned. The programmer must also list the variables that are to be assigned values from this stream. Let's concentrate on the C++ programming language, which uses its input stream name, CIN, directly. A stream used for the input, CIN. CIN, pronounced C-in, that's one way to say it, is the name of the input stream in the C++ programming language. When you use a CIN statement with a list of one or more variables, you are assigning data from the CIN channel to the variables that follow. Anything that was sent to this stream will eventually end up in the variables connected to the stream. The syntax for using the CIN stream goes as follows. You name the stream CIN. Then you follow with an extraction operator that indicates something is being pulled out of the stream and sent into a variable. The word extraction means pull out. That's why when you get a tooth pulled by the dentist, it is called an extraction. The extraction operator is this double arrow symbol, the symbol there. Next, you list the variables that you wish to load, assign, with the value that came from the stream. Let's look at some examples. int, second val. Cin, symbol there, second val. String, my real name. Cin, the symbol, and my name. In the first example, we are taking a number, an integer, from the cin stream and assigning it to the variable second val. In the second example, we are taking a word typed at the keyboard by the user from the stream cin and assigning that word to the variable my name. Notice how the variables always appear to the right of the extraction operator. On the CD, C++ has one of the simplest approaches to getting the user input for assigning variables. Compare the previous example with these ones written in BASIC and Java, respectively. Assigning two variables at once. When you wish to assign more than one variable at a time with input from the user, you need to use the extraction operator before each variable in a list. We use the cin stream followed by the extraction operator. The first variable we are assigning the extraction operator again, and the second variable, remember we are assigning two variables with two numbers extracted from the stream. In both examples that follow, more than one item is pulled from the stream, so the extraction operator is placed in front of each variable assigned. Cin, the symbol, the first value, second value, int a, semicolon, int b, semicolon, int c, semicolon, cin, symbol a, symbol b, symbol c, semicolon, / 3 variables are assigned. Note: any input from the user will first travel to the cin stream. You need the extraction operator, right there. If there is more than one number or word of input, put the extraction operator before each variable. You need a variable for each value, and the variable should have the same type as the expected value. Tip: as the user types at the keyboard, she may make a mistake and needs to backspace or delete. Her data will only become finalized after she presses the enter or return key. Then the data goes to the input stream. Summary: in this chapter, you learned that the variables are the holders of data. Different types of variables were introduced: integer, real, character, and string. Next, the topic of declaration, or how a variable is first introduced in a program, was covered. If a variable is not introduced, the computer will not know what the variable's role in the program is. Furthermore, the computer will not know how much memory to set aside for that variable. Programs consist of statements which proceed in sequence like the algorithms mentioned earlier. Statements are like the sentences which have punctuation to show that they have terminated. Most computer statements end in a semicolon. Each computer statement has its own grammar or syntax which must be followed rigorously. Finally, the topic of assigning variables and who does that assignment, the programmer or the user, was discussed. If the programmer assigns the variables, we expect to see an assignment symbol surrounded by the variables on one side and variables or values on the other side. If the user assigns the variables, the user will type values at the keyboard. These values will be sent to an input stream. Variables are assigned values that come from this stream. This is how the user can assign values to variables.